Electroscopes are able to detect small amounts of electric charge. We know that if we put a neutral object near an electroscope, nothing will happen. But if we bring a charged object near an electroscope, it is able to detect the electric charge, and we can even deposit some of that charge onto the electroscope. So electroscopes are able to help us to determine what type of materials are good conductors and good insulators. So this is a short list of good conductors and insulators and some in between. So good conductors are metal, water, and the human body. Good insulators, wood, rubber, glass, plastic, and dry air. And kind of in the middle, semiconductors, silicon, cotton, wool, paper, and moist air. So let's start with metal. So copper is a metal. So we'll tie this copper wire around one electroscope and connect it to the other. So that should give a pathway for the electric charge to flow from one electroscope to the other. And we see yes indeed very quickly the needle of this electroscope was able to detect the charge as soon as I put it on this electroscope. Likewise, a metal bar, a little bit thicker piece of metal, but metal nonetheless, should do the same thing. Let's try a piece of rope. So you might think that rope is a good insulator, but remember that the semiconductors are things like wool and cotton. So I'm not sure what this rope is made out of, but we'll see how well of a conductor or insulator it is. All right, so the needle did move eventually, but not nearly as quickly as it did with the metal. So that's a good illustration of a semiconductor. Okay, but plastic is a good insulator. So if we take a plastic ruler, we should see no charge travel whatsoever. All right, so unlike the semiconductor, it doesn't even move after a while. So I can put even more charge on and nothing's going to happen. How about wood? So wood is a good insulator, we said. But what happened there? So pretty quickly, the needle of the other electroscope moved. So wood is, in fact, a good insulator, but what is also present in wood? Water molecules. So water molecules, we know, are good conductors of electric charge. So the water molecules, over the short distance of the small piece of wood, are able to conduct the electric charge. But as we increase the distance or the length of the wood, we can see that the charge is a little bit more difficult to transfer. So if we take a meter stick and put some charge on there, the meter stick's a better insulator than the block of wood, but still charge will travel. But if we increase the distance between the electroscopes, making the electric charge have to travel further through the wood, we'll see what happens. All right, so it's having a very hard time actually conducting that charge, even though there are some water molecules in the meter stick. So finally, it did just move a little bit. So yes, wood is a good insulator, but it's hard to get all the water out of wood, which is a good conductor. Now last, the human body, we said, was a good conductor. So what if I were to put some charge on my finger and touch the electroscope? Will the needle move? No. And if I just put it near it, nothing. Okay? So even though the human body is a good conductor, the charges will not flow from me to the electroscope because what else is my body doing? It's touching the ground. And we know that whenever things are grounded, the electric charge will flow to the ground and into the earth. So unless I was able to somehow hover above the ground, there's no way I'd be able to deposit any electric charge onto the electroscope.